Okay, let's start now. Okay, second part of the lesson, we will focus more on the curvilinear motion, and we start to introduce you axis system. Previously, we are so used to x and y. Now we introduce you to normal and tangent component. This one during it will normal tangent always link with the curvature motion. Right? Every time you see a curve, you see a curve motion, then all the equation that you learned in this session will you need to apply that one. Huh? Okay, let's say you have an object moving along the green path here. So at that particular time, this object reached this position. So on the curvature, you know that all the curves have one center. So we label the second location here O prime. And from that position, we labeled new coordinate system. We use tangent and normal direction. You see the T means tangent, the N means normal direction. Then you know that vector have vector unit, like what you learned in Cartesian plane, x, y, z, your unit vector is I, j, and k. When you learn in curvature motion, we will incorporate unit vector for tangent and normal direction also. If the direction is along T, we'll use UT to represent the vector unit. UN means the direction to the normal direction, or pointing inside the curve. The relationship between normal and tangent, same as x and y, always 90 degrees. Okay, the rest you read, huh? What mean by planar motion? Planar motion is a three-dimensional motion. It's like moving along a piece of A4 paper. This is planar, plan. You move on the piece of paper. It's called planar motion. Tangent, it have behave similarly like your V. Tangent always yeah. And tangent axis, the pointing arrow, you're always referring to the direction of the particle. So for example, this particle move from the top to the bottom. So the T will move positive towards this direction. Okay. So this graph is just tell you that all the curve will have a different center. Each curve will have different center for the curve. So the first set will be this one, second set will be this one, third set will be this one. This one will show you why the center of curve is here, because it's curving in. All right. And from here, you need to recall a mathematics equation when you learn about radian, theta in radian, S and R, the small section of a circle, you use S equal to R theta to find the circumference of a small pi or small circle. So you need to recall this one in this session. In this case, we will replace the R, the radius length, as rho, but it's the same meaning. Huh? It's just a symbol to separate that in this chapter, you use rho. Okay, the radius of curvature, we use rho. Huh? Okay. We start to go deep into mathematics derivation. So velocity, you know that okay, velocity, you know that it's vector. Vector has magnitude and direction. So V is a speed or magnitude. The UT that I mentioned just now on the previous diagram, We use ut to represent the direction. Okay, in Cartesian plane is I, J, K. Here we use ut. Okay, ut and un. So the rest is what you learned previously. Start from this chapter, we will simplify our notation. When you see something on top of the parameter, s dot means you differentiate towards time, one time. If you see two dot means you differentiate double differentiation of the time. Okay, so because the equation is getting longer and longer, so to save time in writing the over dt, this one. Okay, acceleration also same. You know the acceleration definition is a equal to dv dt. So just now the v given as ut. So acceleration is a time differential of vector, right? Of this vector. You need to use the chain rules, right? So when you differentiate your vector, this one, you will get this equation. Okay, this one, chain rules are, you differentiate this one, you hold this one, differentiate this one, plus hold this one, differentiate this one. You will arrive at this equation. Okay, so you get a equal to v dot equal to, v dot means your velocity differentiate by time. Then v dot ut plus v ut dot, this one is the chain vector calculation in appendix B or C. You can see in the canvas. So again, here we focus very deeply in a vector. How to draw vector diagram? You always, let's say you have two vector A continue with vector B. The starting and end point you join, you get resultant C. You have to know how to draw the vector diagram. So from here, C equal to A plus B vector. So this is how you write the things. So UN and UT is original vector direction. But what happens if there is a change of position? Let's say you have a change of position, your tangent direction change a little bit the theta. So when you have a change of angle, your ut become u prime t. U prime t means second location of your vector. And there's a change of vector here, du. So by using the vector diagram, vector 1 plus vector 2 equal to resultant vector. Okay, this is a start, end. You join start and end, you get resultant. So based on the vector diagram that I draw on the whiteboard there, so this is A, B, C. You want to get this one, you can this arrow is u prime t. Don't confuse with the angle. This one equal to this one plus this one. Okay. Okay. Here I go very fast because I don't test you on derivation, but I need to explain how you get that. Okay. So in vector form, this one comes from a diagram that I explained just now, right? From this diagram, this black arrow equal to this one plus this one. So that's why you get this equation. Okay. Then the ut, this one, the change of the unit vector t is a very long infinity radius. So we will use du equal to 1 because it's very, very long. So magnitude of du, this is a vector. So vector have magnitude and direction. So when you do calculation, mathematics, du equal to 1 d theta, but this one is just to show you there's a mathematics behind. You don't need to derive in your test or final exam. Direction is un. You will get one equation, dut equal to d theta un. Then you derive the time differentiation, this one. Okay. Okay. So what does it mean here? Means you differentiate. Okay. This one is from. Okay. This one you read lah from the derivation. At the end, what is important is this equation. Okay, I go very fast. Go very fast. Important is these slides. Okay, so when you see curvature motion, most of the time you need to use this equation. A equal to, you have two components, tangent component and normal component. So you write AT, UT, this is magnitude, this is direction, plus AN, UN. Okay, so you always have two direction with its tangent normal because we are now in a curvilinear motion. Okay, so memorize this one. AT equal to V dot. V dot, what does it mean? You differentiate your velocity with time. What is your AN? You need to memorize. AN is V squared divided by rho. What is rho? Radius of the curve. All right. So memorize this one, this equation. Right. Every time you see a curvature linear motion, write this equation, you'll get 3 marks. Okay, this one is important. I won't ask you how to derive the equation. I will ask you how to apply this equation. All right. Okay. To apply this equation, you know that you have a curve, right? On particles that moving on a curve, let's say this particle move in with a V, you know that particles, every time you see particles, straight away you establish two axes with its normal and tangent. Okay. All right. So normal tangent. Your next question is, how do I find my V? How do I find what kind of V component that I should use? Because you know that your V can always split to X and Y direction, right? So, but anyway, when you come to this equation that you see on the screen there, your V always is your velocity at tangent direction. Okay? There's no velocity in normal one. Velocity always tangent to the curve. So the V here, you always use the resultant velocity. I mean the final the velocity at tangent direction. Here same also. Acceleration also use the VT direction. Okay. Because in some case, we will confuse you. We will write something on the diagram, then you confuse. All right. And recall the equation that we derived earlier, A ds equal to V dV. We will use this equation also in some of the solution. So it's a pair with the one that I wrote on the whiteboard here with this one. Okay, what is important in this session is that this equation, acceleration, you have two components, normal and tangent, and what are the equation is there. So what is AT, how to find AT? The time differentiation of velocity, how to find AN, fixed already, this equation, V squared divided by rho. Okay. Okay. Because most of the time, sometimes we give you the equation of velocity, then you differentiate, you get acceleration in tangent. Then you find the normal component. Then you find the resultant acceleration. Okay. So this is what I mentioned just now. So once you have your AT and AN, you can draw diagram on your free body you can draw axis or vector on the free body diagram. AT always tangent to the curve. AN always pointing into the center of the curvature, which is O naught, or in the exam, if you don't write O naught, you write O also can, I give you correct. It means that you are pointing to the center of the circle or the curve. So AN, AT, both of it always 90 degree. So this is a vector. Vector, you can find magnitude and direction. Okay, the magnitude is square this one plus square this one square root. You get this magnitude. Direction, same, trigonometry. Tangent, sine, cos, then inverse, you inverse it. You get the angle from one of the axes. Okay, normally we will refer to the tangent axis. Okay, so this one you're familiar with the previous example. So this is another highlight. Just now, you know where is the direction of the curve, right? If this particle move from the left to right, so this one, because it's curved in, so it will pointing in. The normal will pointing in. Tangent will always pointing out. Not pointing out, but towards the motion of the particles. And it's 90 degree. Okay. Then same, this one. So this one, the normal is pointing this side because curve pointing here. This curve pointing here. What happened? It will tell you the object is moving along the curve. In this case, your acceleration become tangent direction because straight line don't have curve. When you don't have curve, you don't have normal component. Sense? So this will be the part is tricky part. Most of the time, we will ask you, it will beginning with the straight line, then you will forget when you join with the curve section, you will forget that actually you are given the acceleration in a tangent component. Okay, remember that, huh? So when an object moves in a straight line along the path, you're actually given the tangent component answer already. Okay, then when you have AT, means you have a A equation, you can find velocity by integration. Okay, why? Because A equal to dv dt, A equal to dv dt. You want to find V, integrate. Okay, you get V. Okay. Three-dimensional, most of the time I won't ask you in three-dimensional. But if you go out work later, or you work in a master program or design projects out there, you deal with robotics, then you need to consider the motion in another axis. In this case, just now we are working all our calculation in a plane motion or plane motion, which is the highlighted one. This is like a piece of paper. Then N and T. The Z direction, in this case, we use B to represent your Z direction. Because we don't want to confuse with the other Cartesian, other coordinate system. So for three-dimensional, for B, we use it to represent Z direction. So as we go deeper, second half of, now we are looking at particle. Particle, we don't have all this mass issue, but later chapter, when we go into rigid body, then we will look into this formula. How to write this formula? UV equal to UT cross our UN. If you look at the table, you use your right hand rules. UV is your thumb. UT cross to UN, you get UB. So when you cross your finger curve, right? So when you curve UT to UN, you get UB. This is how you use your right hand rules. Huh? So you want to find where is your UB. All these are 90 degrees to each other, but you want to find the angle or the cross product or dot product. Every time you use right hand rules is under cross products, means vector cross vector. So this one cross this vector. There's a calculation there, right? So refer to appendix that I attached. Huh? Same. What happens if you want to find the UN results or products? Thumb always what you want to find, right? So you want to find UN. How you do? You curve your finger, right? So you cross UB to UT. Right? You cross, right? You put like this, then you cross UB cross to UT. Then you do the mathematics steps. Okay, right hand rules. We will look into this maybe after week 7. After we done particles. These are the proposed steps to solve curvilinear motion. So it's the same. First, always go for coordinate system first. Draw the normal and tangent, right? Then know where is the positive direction. Because we will test you to get negative, then we'll ask you to explain the motion. That is the challenges lah. Okay. Velocity will always tangent, like what you learned in previous section. You always tangent to the curve. This one you read, huh? Okay, so when you have constant acceleration, you can use back the 3 famous equation. Okay, S, V, and V squared. So the previous 3 equations that we learned, you can apply in many, many chapters. Huh? So this is one of it. And we highlight just now how to find the normal component for the acceleration. V squared over rho, with I write on the screen here, is a new set of equation you need to memorize. Huh? Okay. Then there's one more complex equation you need to memorize to find the curvature radius, this one. Okay, rho equal to something very lengthy, it won't be given in the exam. You need to memorize. As you can see, the form, the curvature radius equal to top portion 1 plus derivation of dy dx power 2 cross bracket, then power 3 over 2 means you power 3, then you square root it. Then bottom one is double differentiation of your y and x. So you need to refresh. Your differentiation is very important, differentiation skill, to find this one. Sometimes if the question asks you to find this radius or something missing in this equation, there is a way to find this value by using that equation. Okay, but if the question already give you the radius, means you don't need to use this equation. Okay, so these are the part lah. Important is this formula. Okay, this one and this one. We look at example. So let's say you have a skitter. You drop from the projectile. So a skitter reach point A, right? Reach point A in a parabolic path given by this formula y equal to 1 over 20 x squared. At a speed of 6 meters per second, which is increasing at 6 meters per second square, it gives you velocity and acceleration at the same time. Determine the direction of its velocity and direction of the magnitude of its acceleration at that instant, means you freeze the time and you look at what happened at that point. Ignore the size of the skitter at this moment. How do you solve this kind of question? By applying what you learned 10 minutes ago. So you're given the initial, not initial, at that particular time when you freeze the location of that object. 10 from the ending point, 10 meter, and the height is 5 meter. How do you find how you solve? First, draw normal tangent direction. You know that you're given parabolic, and this is a quadratic curve. You know that quadratic curve, like I mentioned yesterday, y equal to ax squared plus bx plus c. If your a more than 0, you have a smiling face. You have a less than 0, you have a sad face. So this is a smiling face with an a positive. Draw a and t straight away. Yt pointing this way because the object moved from top to bottom. Don't draw this direction. T always follow the object direction. So again, when it comes to test or final exam, some of you will turn this axis to another one because you're so used to XY direction. So you need to follow the object direction. So T is pointing this way, means all the direction going down is positive, go up positive. Not go up, but towards the center of the curve is positive. Then you put in the VA. So you know that you're given the speed at that instant, you add the curve. You add the curve, so you know that at the curve and at that instant, you have the VT already. You have the VT component already. Okay? And then you can put in the angle theta referring to horizontal axis X or to the ground level theta. Okay, coordinate system, you put in AT axis and A along the axis. Velocity, I put in the green sign and I take out all the other data. I draw on the screen. So you have the path, the N and T axis, and the V is given because it's moving tangent to the curve. So VA is 6. You know that you already have VT. And you have equation. You have equation, y equal to something. So when you see something like this question have a curve, you have two equations to memorize. One is A, and another one is the equation I show you, the curvature of the radius. You're not given radius here, right? So you need to apply the equation just now. So first derivation, dy dx, you get 1/10 x. Okay, who cannot see how to do this one? Who don't know how to get this? It's a differential steps. You differentiate one more time, you get 1/10. All right, you get 1/10. So dy dx at 10 meter, you have an x component here. You substitute your boundary condition 10 inside here. Your dy dx is 1. So dy dx actually is the gradient. Gradient also can find angle. So tangent theta equal to 1. It means that your theta equal to 45 degree. Okay, at this point, you find the gradient, means dy dx is 1 means it is at 45 degrees. Okay, means that your V is a vector, VA, magnitude is 6, 45 go down from the horizon. 45 degree go down from the horizon. Okay. What about acceleration? Recall these slides. Remember, AT equal to this one, AN equal to this one, and the magnitude is a square plus square root. So recall the equation that you see on the screen just now. So AT is given because it's give you 2 meters per second square. So put your AT there. So your AN, you put in overlapping the free body diagram. And you have two vector, you need to find the resultant. So you use the vector diagram procedure. You draw a line, then you join this one. Or you take this one, put here. Okay, you draw an arrow here. Okay. Then I put in the angle referring to this from the normal axis there. So recall the radius equation. Do integration, do differentiation. Substitute value here, substitute value here. You'll get radius equal to 28 point something. Yeah, I won't go deep into this one, but you'll get a reference answer, 28 point something. Important is this equation, how you apply, you get the answer. Why you need this one? Because you need to find the normal component of your acceleration. And it's not given in the diagram. Okay. Then you substitute. Again, you see V, we use the tangent velocity, 6. This one you get 2 because it's given in tangent direction. Right? You do calculation, the answer will be 2 point something. So your acceleration is 2 point something, and then from there you do calculation for the angle here. So how to find angle? You have this magnitude, opposite and side. Right? Tangent is, this is 2, this is 1.2. You get the angle here. So 57 point something from there, but there's a way you're referring to horizontal ground. The angle is 12.5. How to get 12.5? I give you the answer on my slides. You go and figure it out. This is the steps to get 12.5. You draw the diagram, you flip a little bit, you think a little bit, then you can get this one. Okay, so there's a note for you to help you to. Normally, the question will say, give direction referring to the ground level. So once you find this one still not enough, you need to find referring to ground, and then you need to draw the arrow. Okay, so this is a complete marks. You give magnitude and direction. Okay, okay, 2 more examples, right? Just to refresh back what you learned. Always same, always same. I want you to observe the pattern here. Right? I want to observe the pattern. So you have a race car, not race car. So race car moving in a circular circuit, and this circuit is like a piece of paper. Is a 2D dimension question, right? You're given the R here, means you don't need to calculate the R, the radius for the curve, right? So you're given the radius 300, increase its speed at a constant rate. The speed increase at a constant rate of 1.5 meter per second squared. This is acceleration. You're given the A. Your A is constant. Starting from rest, you are given the initial velocity, 0. Determine the time it needs when it reach your acceleration is 2 meter per second square. You given initial acceleration, final acceleration, find the speed at that instant. You need to find the V at that instant. So first, still the same, draw normal tangent axis because it's a curved motion. So which one is normal? Which one is tangent? Normal always pointing to the center of the curve. Tangent always follow the motion of the object. So N and T. Not T go up. So just be careful on that. Then I just add in the component I have, AT and AN. And I draw A for that vector diagram. All right. Now, normally you deal with normal tangent, then you have velocity, normal tangent, acceleration, normal tangent, find magnitude, find angle. Normally is that for this chapter. So coordinate system, we already done. For acceleration, at tangent direction is 1.5, is given there. Tangent direction, normal, there's an equation to calculate just now. Again, memorize. An equal to v squared divided by rho. Rho is given here. Okay. There's one time I asked about same question, but I did not give you the R. I asked you to find R. So go home, go and find what is a circle equation. Go and find y equal to something one. I do come up one question, same one. I remove the R. I want to test you to write circle equation in your answer to find the R. You need to memorize the curvature equation. You differentiate this equation. Differentiate one time, differentiate 2 times. You substitute, you find R. Okay, it's a bit complex because it's 1 over something. That one. So you will test your differentiation skill. That one. Okay, go home. Your homework. This one. I just give you some idea. Sometimes you see the same question, but I change a little bit. You might not get ready, then you cannot do. Okay, so because the nature of the question, you can use the V motion equation. The V equal to V naught plus A T. Initial start with rest. So V don't have. You get one equation. So your V equation is 1.5. T is a linear equation. So from here, 1.5 T is a velocity. You know that acceleration is V squared divided by rho. You substitute inside there, you'll get equation in the T form. You have AT, AN. You substitute in, you find the time. There's only one unknown there, T. Okay. Solving, you get the positive time because square root, you always get negative positive answer. Take the positive. The reference answer for time is 13 point something. Okay, makes sense to you? Yeah. You always repeat the same procedure. How to find the speed? Once you find the T, substitute T into the early velocity equation. Okay. Reference answer, velocity is 119.9 something. We go for one more, then we stop. This is a conveyor question that you see in the industry problem. There's a box travel in the conveyor. So the box start with rest at A. I give you all the diagram. At A. So it increase its speed such as AT equal to 0.2 in second. Determine magnetic oscillation when it arrives at point B here. You have a linear issue, you have a curvature issue. You have a linear motion, curvature motion. How you solve? First, no matter how complex it is, you see curve straight away, draw normal tangent axis. Normal pointing in, a B normal pointing in, although here is straight line, but it's at the end of the curve. It's at the end of the curve, so it's normal still pointing in, tangent going this way. Acceleration, 0. Velocity given, acceleration given 0.2 t. You want to find the velocity, you integrate. This is the equation given. So dv equal to 0.2 t dt, you got dt something on the left, d something on the right, you do integration. Okay, so I'll go very fast here. What is need to highlight is the limit that you use. You start from 0 to v, for v on the left hand side, and t you start from 0 to t. I saw some students, they have struggled with the limit. They don't know from where to where. Again, this is tutorial question. When it comes to final, sometimes the v is not 0. Huh? This example is, let's say, start from rest. When it comes to test 1 or assignment, there is a speed there. So this is not 0. You have v1, v2. Okay. So you get one equation from the integration, v equal to 0.1 t squared. Then you recall in the first session, you learned v equal to time differentiation of position, 0.1 t squared. You continue working from here by using the velocity definition. Integrate one more time to get the s direction, s equation. Okay, you get s to reach b location equal to linear, cubic equation, 0.1 divided by 3 t cubed. Okay, up to here, you are being evaluate the simple definition of velocity and acceleration, acceleration. Yeah. Okay, everything makes sense to you. So if you cannot do integration, you cannot reach here. You need to do integration, then you continue to recycle, you get another one. So you have two new developed equation. So how to find? You have this equation tell you the distance traveled after a certain time, which is from here to here. Can you find the distance from here to here? It's actually this 3 meter. This is a curve, right? Or a circle. So it's a quarter circle, right? So what is the equation for circumference of circle? 2 pi r. So this is quarter. So you divide by 4. Okay. This is quarter side curve. So you divide by 4. Right? So you get your s equal to 6 point something. You have this answer, substitute in, you can find the time. Okay? 5 point something. Okay, so yeah. Then you substitute the time back here, because just now you find your v equal to something 0.1 t squared. Substitute back here, you get your v. Okay. Then you have the acceleration in tangent direction. What about the normal? So most of the students, they stop at AT, they forget about the AN. So recall back AN equal to V squared divided by rho. Rho radius is 2 meters given. Substitute the velocity you find just now. You get tangent acceleration, normal acceleration. Again, vector, you need to find resultant. Square this value, square this value, square root, you get magnitude. Angle, okay, there's a magnitude there, right? Right. So in this case, it just stop at acceleration. It just asks you the magnitude. It do not ask you direction. Okay, so far we stop here. Next lecture, we will study radial polar coordinate.